Okay, today we're going to be learning a new method for factoring trinomials.
Woo! Love that shirt!
You know, you girls need to calm down a little bit. Boy, I tell you, in my day, students would have never done that to a teacher. Anyways, I guess that's fine. They don't mean any harm. Anyways, what we have is the method that we're going to be using today is when the coefficient for x squared is 1. And most people, most mathematicians do this, most math books I've seen do this by, it's just a giant guessing game. And that's not a good way to do this. Now Mr. Wallace does this, a variation of his grouping. And I'm going to show you a whole different way to do this. The way we do this is we're going to factor 24 into two numbers. Now if we were going to factor 24 into two numbers, now not prime numbers, just two numbers, any two numbers that will give me 24. The first one would be 1 times 24. 2 times 12 would be our next possibility. It could be 3 times 8. And our last possibility would be 4 times 6. Now I say our last possibility after 4, what would be next? 6, but that would be 6 times 4, and that's just the reverse of this. And then we'd just be going backwards. We'd be doing 8 times 3, and then we'd be doing 12 times 2 and 24 times 1. And all we're trying to do is get different numbers. And these are the only 4 possibilities. Now, since when we multiply two binomials, do you remember what happens to the middle nomial? It's not an addition, it's not a multiplication problem, it's an addition problem. Okay? That's going to be a multiplication problem, and that's going to be a multiplication problem, but this is going to be an addition problem. Maybe that's helpful, maybe it's not. But this is what we're going to do first. Okay, we're going to factor this into two binomials. Remember I told you that a binomial times a binomial is a trinomial, and the only exceptions to that is the difference of squares. That's not what's going on here. And a quadnomial, that's not what's going on here. So if we have a trinomial, we're going to be able to factor it down into two binomials. That is, if it can be factored. Now maybe this can't be factored. Well, spoiler alert, it can be factored. But you're going to get some trinomials that can't be factored. And so how do we factor it? We'll set up two binomials. And we're going to have x times x, right? To get x squared. How else are you going to get x squared? X squared times 1? Try that. That's not going to work very well. Okay, so we're going to have, it's always going to be x times x. You know, unless we have a different variable through here. I mean, that could be a squared 2a minus 24. But if that's the case, then we'd have a times a. But we got x times x. And what two numbers are we going to put here? Any set of numbers, I have 4 sets of numbers. They all are going to work if all I want is a 24 or a negative 24 actually. We're gonna just ignore that negative right now. We're going to just say 24 even though you know it's negative 24. 24. Any one of these sets gives us 24. But only one of these sets is going to give us 2x. So how do we get to 2x? Look at all these factors that I've done. Can any of them be added or subtracted to get 2? Remember, the middle nomial is we get that through addition. This we get through multiplication. This we get through multiplication. But the middle nomial we get through addition. Okay? So if I add 1 and 24, Well, that's going to give me 25. That doesn't work. What if I subtract them? Well, 24 minus 1, that's going to be 23. That doesn't work. Okay, so let's cross that out. Let's try 2 and 12. Let's see, 12 plus 2 is 14. That doesn't work. 12 minus 2, that's going to give me 10. That doesn't work. Okay, how about 3 and 8? Well, 8 and 3 is 11. That doesn't work. 8 minus 3 is 5. That's a lot closer, but that still isn't working. So all we have left is 6 and 4. 6 and 4 is 10. That doesn't work. 6 minus 4 is 2. That does work. Okay. So let's put 6 and 4 in our binomials. Okay, and as you can see, I have avoided plus signs and minus signs, and there's a good reason for that. Now, in most systems, they use plus signs and minus signs to guess, and it's really a nightmare. I used to do that until I figured out this way, and as you're going to see, this is really nice. Okay. Now, how do I get to positive 2? 4 minus 6? No, that's negative 2. So 6 minus 4. And that is our answer. And I'm going to tell you, in most systems that I have taught out of, I don't teach that system, but the books that I've used, they say, okay, write all 4 of these possibilities and now give me all the possibilities of that. Well, you can have 12 minus 1, you can have 1 minus 12, you can have 1 plus 12. It just gets crazy, especially when you have 4. Now, sometimes you'll only have 1 or 2, and that's great. But as you can see, when we have 4, it can get really complicated. And so doing it this way is just a lot simpler. Now let's try another one. We're going to be doing quite a few problems, and each problem we do, we're going to be doing quite a bit faster. So just hit that pause button if you need to. But let's tear apart 18. Okay, our 3 possibilities is 1 times 18, 2 times 9, 3 times 6. Now let's set up our binomials. Okay, we're trying to get to 9x. Can I add or subtract 1 and 18 to get to 9? Nope. Can't add or subtract that. Can I add or subtract 2 and 9 to get to 9? No. Can't. Can I add or subtract 3 and 6 to get to 9? Well, if you add them, you'll get to 9. If you subtract them, you won't. So that works. Let's use 3 and 6. Now our 18 was positive, so both these numbers have to be positive, or both of them have to be negative. So negative 3 and negative 6, that does not get you to positive 9. Positive 3 and positive 6, that does get you to positive 9. So let's put a plus sign there and a plus sign there. And that is our answer. Let's try another problem. Okay, that should be pretty simple. The factors of 3 are 1 and 3. So I'm not going to even write that down. Let's put our binomials together. Yeah, x times x is going to be x squared, and 1 times 3 is going to be 3. And it doesn't matter if you put this one first or this one first. You could have put 3 here and 1 there. It doesn't matter. But our signs do matter. And let's look at our signs. Let's see. We got a plus 3, so we got to multiply 3 times 1, or we have to multiply negative 3 times negative 1. Well, 3 plus 1 equals positive 4. That's not correct. Negative 3 plus negative 1 equals -4. Well, that works real well. And that is your answer. I hope these are getting easier. Let's try another one. Okay, now let's tear apart that 20. Okay, can we add or subtract 1 and 20 to get to 8? No, I don't think so. Can we add or subtract 2 and 10 to get to 8? Well, yeah, if we subtract them. And just because we found a good one, there might be a couple of good ones. So let's go through all of them. Can we add or subtract 5 and 4 to get to 8? No, we can't. Okay, so our answer is going to be 2 and 10. Okay, and that is correct. The only thing that is missing are our signs. And so let's look at the 20. We're multiplying 2 times 10 to get to 20, but it's a -20, which means what? 2 or 10 has to be negative. They can't both be positive. +2 times +10 is not -20. And they can't both be negative. -2 times -10 is +20. So only one can be negative. And which one is it? Well, 10 minus 2 is +8, so it isn't that. 2 minus 10 is -8. So that's where our negative is going to be. And that is our answer. Now let's try something a little trickier. Oh, well, that has a lot of things going on. We're not using x anymore, which, I guess is fine. We're using a squared and it has a coefficient of 1, so that's within the parameters of what we're doing today. But we have two variables. We have a b and we have a second square. We never had that before. Well, that's not going to matter a lot. And let me show you why. Well, since we're starting off with a squared, we're going to put a and a in the first position of our polynomial. But we have a b squared up here. I know it's 14b squared, but let's concentrate on the b squared. Well, b times b is going to give us b squared. So now all we need to do is tear apart our 14. And our possibilities are 1 times 14 or 2 times 7. Well, 1 and 14 will not give us our 9. 2 and 7, that'll give us a 9. So let's put 2 and 7 against the b. Okay, not against the a, but against the b, because we're going to end up with 14b squared. Okay, not a squared, 14b squared. So we're going to have 2b times 7b. And it is positive 14, so they're both going to be positive, or they're going to both be negative. Positive 2 and positive 7, that doesn't get us to -9. -2 and -7, that does get us to -9. And if that still seems funny, multiply this out. If you don't believe that this is going to equal our trinomial up here, multiply it out. You know how to do that. And if you do, you will see that that's correct. But if you're unable to look at that and see that that does equal this, if you can't see that with your eyes, then multiply it out. Because it could be the case that that there is no factoring for this. Now we just proved that there is. But if there wasn't, then our answer is no solution. So multiply this out and see, after we have factored everything, after we've torn everything apart, put it back together again. Check your work, especially on a test. Maybe for your homework, you don't feel like you have time to do all that testing, but boy, for a test, you better take it apart, put it back together again, and check your work and read the question again. Okay, that looks pretty simple. Let's put our binomials together. And let's tear apart our 6. So our factors are 1 times 6 and 2 times 3. Can we add or subtract 1 and 6 to get to 5? Well, yeah, if we subtract them, 6 minus 1 is 5. And can we add or subtract 2 and 3 to get to 5? Well, if we add them, okay, so let's see, which one is it? Well, both of them are good. That's why I told you earlier, run through them all, because sometimes you have two solutions. Now, there's only one correct solution. So let's try to work this out a little bit. Negative 6 means we're going to be subtracting. Two minus 3, that gives you negative 1. 3 minus 2, and that gives you positive 1. So 2 and 3 aren't going to work. So let's put 1 and 6 in there. Okay, that's good. And I'm going to try to be real careful because so far they're trying to trick us with two solutions. So I want to make sure I get my minus signs and plus signs in the right place. Now let's go back to negative 6. That means one of these is going to have to be negative, and only one can be negative. So we're going to have to subtract. And we're going to have to get to positive 5. So 6 minus 1 is positive 5. That works. Okay, it's not going to work the other way around. 1 minus 6 is negative 5, so that doesn't work. 6 minus 1. And that is the answer. Now let's try two more problems. We have x squared plus 2x plus 6. And our binomials are going to be x times x. And let's tear apart that 6. Now, like the last problem that we saw, 1 times 6 gives us 6. And 2 times 3 gives us 6. Can we add or subtract 1 and 6 to get to 2x? No. Can we add or subtract 2 and 3 to get to 2? No. What's the problem? The problem is there's no solution. And I told you you're going to run into that every once in a while, and this is a perfect case. There is no solution. You cannot factor this trinomial. But let's try one last trinomial. Okay, let's factor this. What's that? I promised you that that has to have a 1 in front of it. That's right. I told you that to do what we're doing today, you need a 1 in front of that x squared. But I told you something else too. What did I tell you? I told you that the order of factoring was sign, number, variable, polynomial. And you jumped right to polynomial. You jumped to the end first. Okay? Now, the problem with this order of operation for factoring is you kind of get lulled to sleep after all those x squares that we've been doing. Well, what would happen here? Well, I don't need to factor a sign. Can I factor a number? Well, I could factor 3 out of here, but can I factor 3 out of here? And yeah, I can. So why don't I do that? Why don't I factor 3 out of all of those terms? Well, now we have that x squared that I was promising you. And we have something that is pretty simple to factor. Let's kind of ignore that 3 for a while. We're going to keep bringing that 3 down as we factor. But let's pull apart 15. Isn't it nice we don't have to pull apart 45? Let's pull apart 15. Yeah, we have 1 times 15 and 3 times 5. That's the only possibilities. And before we get involved with that, why don't we bring down our two binomials? And you forgot to bring down the 3. That's right, when you factored this out, we ended up with 3 times this trinomial. So it's going to be 3 times these two binomials. I think that makes sense, doesn't it? I know it does to me. And so let's see. Can I add or subtract 1 and 15 to get to 8? No. Can we add or subtract 3 and 5 to get 8? Yes. Okay, and what are our signs going to be? Well, we have a positive 15, so they both have to be positive, or they both have to be negative. A positive 3 and positive 5 will not give us negative 8, so how about negative 3 and negative 5? That is good, and that is your answer. Don't forget to do your homework.